Hello and welcome to today's webinar, The Top 3 Secrets for Exploiting Mainframe Automation and Analytics, brought to you by BMC Software. My name is Jasmine Henderson, and on behalf of Share Headquarters, I would like to thank you for joining us today. Share is pleased to continue our webinar programming with informative and educational events. Please note that presentation slides and recording will be available post-webcast at www.share.org. Today's presenters are Ross Cochran and Barry Williams. Ross is a principal software consultant with BMC Software. In this role, he helps his clients maximize the value they receive from their BMC R4 solutions. Ross has worked in IT since 1977. He holds a bachelor's and master's degree in computer science. Barry is a principal software consultant for BMC's MainView and R4 cost optimization solutions with over 35 years of experience in system management. We encourage you to submit questions through the event via the Q&A box on our webinar toolbar. We would like to now turn the webinar over to today's presenter. Please go ahead, Barry.
Thank you. Good morning. Good afternoon. So today we're going to talk about proactive automation, analytics, and automated operations. And then we'll turn it over to Ross, who's going to talk about intelligent capping and modeling. And we're trying to frame this around what we're going to call the closed loop. So when we say closed loop, we're really talking about this integrating analytics with proactive automated operations and intelligent capping so that you can implement a closed-loop solution for systems management. Because really the status quo is no longer sufficient. According to the latest BMC mainframe survey, organizations that are increasing capacity on the mainframe are doing so for several reasons. Transaction and data volumes are increasing, workloads are less predictable, applications are changing faster, and there's a growth of Java on the mainframe. And this is obviously being driven by the digital world, which in turn is driving a need for better systems management solutions. The mainframe, it is a key player in the digital world. The growth of the digital economy is challenging mainframe IT. There's several challenges. There's a growing number of mainframe transactions that are non-revenue generating. At the same time, IT is being asked to reduce cost. Your experienced staff is retiring. So really what you need to do is to capture and retain the knowledge and pass that to a new generation of mainframe professionals. Let's talk about proactive automated operations. If you look at a mature automation solution for the mainframe, it usually has 4 components. You have event management, you have object management, you have console management, and you have subsystem management. And if you look at a typical MainView implementation at a customer site, typically customers are doing performance monitoring, they're doing availability management, they're doing problem determination. But really what we want to focus on today is just talking about extending that to system automation and event management and doing it in a proactive way. So if you look at MainView, we do have a centralized architecture, and at the heart of that architecture is our intelligent proactive automation. This is codeless, rules-based automation. We take advantage of dynamic triggers to invoke appropriate actions. Your thresholds can be based on business cycle changes. And we talk about smart alarms, meaning that only real problems are raised. So when we talk about intelligent, we're really talking about how do you know where the problem is. A lot of times you'll get an alert, and if the thresholds aren't accurate, and there's a wealth of information being reported in that particular event or alarm, in many cases it's hard to determine where the problem is. So you need a more intelligent solution. So let's talk a little bit about persistence and smart alarms. So with MainView, of course, we have persistence built in into our alarm manager component, and this allows you to avoid, false alarms based on spikes in performance. So you do have the ability when you define the alarm to define it in such a way that MainView will take multiple samples, and it will only trigger the alarm if it's true so many times out of those samples. So for example, if you had an alarm and you defined it in a way that the severity will be major if it was true 5 out of the 10 times, but it would be considered a critical severity if it was true 7 out of the 10 times. So just to try to illustrate that, we're going to define an alarm that's going to take 10 samples, 1 per minute. So currently at time 0, the severity is green, meaning everything is fine and it's normal. But say we test the alarm during the first interval, and we determine that we actually have a problem. But at this point, it's only 1 out of 1 samples. So then we test it a second time, and we see it was true the first time, but not the second time. And so as time rolls on, we're going to keep taking samples, and then maybe the condition was raised again. So now at this point in time, it's true at time 1, it's true at time 2, and it was also true 5 minutes ago. But at this point, it's only 3 out of the 10 samples. And as we proceed to take samples, eventually we're going to have the condition where it's true 5 out of the 10 samples. And at this point, alarm manager will change the severity from normal to major. And if we continue to test, and then it becomes true 7 out of the 10 times, and then we will change the severity to critical. So this is the concept of persistence, which is built into the MainView-based infrastructure, into the alarm manager component. It also has the capability to reduce the severity. So it'll remain true as long as it's at 7 out of 10, but if it drops back down to 5 out of 10, then we'll lower that severity to a major severity. And likewise, if it drops below 5 out of 10, then we send out an end of alarm condition saying that it's no longer true. This is just one of the features that we're going to talk about as far as events and alarms and automation. So the next thing we'd like to talk about is dynamic thresholds. If you look at dynamic thresholds in action, this is in comparison to a static threshold, which was kind of the old way to do it. So with MainView, you have what are called dynamic thresholds, and this is where you can define a calendar behind a threshold so that it can have a different value based on the time of day. So in the past, you only had the capability to define a static threshold that was at the same level, all day long. So with dynamic thresholds, you can put a calendar that would represent your business cycle. So if you take a look at this graph, what we had the ability to do is to analyze your workload throughout the day and to determine what we consider to be a normal, in this case, CPU consumption, and that's represented by the green line on the graph. And then we had the ability to define a dynamic threshold that matches that dynamic workload throughout the day, where we had different levels of thresholds based on the time of day. If you look at the red line, that represents, the flat red line represents a static threshold. So typically when people define their thresholds and they were static, that what you would do is try to find the peak CPUs throughout the day, which in this case is somewhere around 1,300 hours. And then in order to be safe and avoid getting alarms all the time, you would set your static threshold somewhat above your normal peak. So if you look at this graph, the green line is peaking at 300, right around 1,300 hours. So typically you would define a static threshold, in this case of say 345. But the problem with that static threshold is that it's really only going to trip during your peak CPU usage in the middle of the day, and maybe if it goes over the 345, then you'll get an alarm. But the beauty of the dynamic threshold is that you know what's your normal CPU consumption based on the time of day. So in this example, if you look at 6 a.m., our normal expected CPU actually exceeded our dynamic threshold. So we would get an alarm at 6 a.m. and that would alert us that our CPU is higher than normal or what is expected at that time of day. So with intelligent proactive automation, there's a quick return on investment. We have a rules-based engine where you don't have to write Rex code. So the rule of thumb is 80% of your automation can be done with rules without writing code. And then, of course, for the other 20% that may be more complex, we do support Rex, and you can write the remaining of your automation using Rex. But the rules engine is more efficient than Rex code, and typically we'll find that one rule is about 1/10 of the overhead of a Rex routine. So the automation is built into the base infrastructure. It's more efficient, takes advantage of our rules engine. It's easy to use, it's centrally manageable. It's easy for less skilled people as far as total cost of ownership and to maintain the rules versus having somebody who's an experienced Rex programmer. So let's take a look at another example. So here we're looking at menu. And currently everything's fine. We don't have any problems, but we do have an alarm that's set to trip if a job uses too much CPU. So in this case, now we have a problem that's detected. It's critical severity. We have a job that's using too much CPU, and the alarm is giving us the name of that job. So in this case, typically you would come in using main view, and then you can kind of right-click on the job, and you can automatically cancel that job, right? Main view based on the alarm, and take action. And once that job is canceled, then main view automatically detects that the alarm is no longer true, and then write an alarm condition. Really what you want to do is to completely automate this. So in this particular example, we got the alarm and we right-click and cancel the job, but there's no reason why we couldn't write an automation rule because the alarms in main view are immediately visible to our automation. And it's very easy for you to go into our automation and define a rule that says this particular alarm is true, and then to take some automated action. And for the next example, you could actually automatically cancel the job. So that's kind of one example of a closed loop situation where you define a smart alarm that's based on dynamic thresholds and persistence, and then build an automation rule on top of it to automatically cancel that job. And another example would be our integration that we have with CompuWare's iStroke. So we do have the ability to, using main view, to detect looping jobs. And then you can take a rule based on that looping job alarm, and you can actually automatically kick off an iStroke analysis and stroke a particular job to determine why it may be looping or using too many resources. It's really just another example of using analytics and closed loop capability and automation. So another example of closed loop analytics and proactive automation, if you look, we kind of talked earlier about dynamic and static thresholds. And And really, this really has become a problem we've seen with a lot of our customers where, you implement Mainview, you spend a lot of time uh, analyzing and creating thresholds and figure out what your peaks are. And in the past, you would go out and define a set of static thresholds. But today, your workloads are dynamic. They're changing based on mobile workload. 24/7, people coming in and checking their account balance 50 times. And so what we found is that customers really don't have the time to go back and adjust their thresholds. Not only the time, but perhaps the skill level. So they find that now that it's 5 years later and all of these thresholds that they defined are obsolete. So this kind of leads to false alerts, and either you waste time chasing down these false alerts, or in some cases you just ignore them. And you really don't have the ability to get any type of early warning, particularly for non-peak unexpected events. So the solution to this is what we call Mainview Threshold Advisor. So what if you could have a solution that could go out there and automatically create accurate thresholds based on your actual workload, to go out and create dynamic thresholds and actually build the calendars behind these dynamic thresholds based on the profile of the workload that we analyzed. This would allow you to eliminate false alarms, to get early warning for non-peak events, and to also implement best practices that we deliver out of the box for which metrics that you should really be concerned about. So just to try to say this in a nutshell, Threshold Advisor is a solution. It's software that will actually connect to Mainview, all the different Mainview monitors, whether it's Mainview for CICS or DB2 IMS or ZOS, and it will collect data, performance data, on a daily, weekly, monthly basis, and then it will automatically do a statistical analysis on this data, and it will automatically calculate dynamic thresholds and the calendars required for those dynamic thresholds, and create what are called threshold recommendations. And then you can set it up in such a way that it will actually, on a regular automated basis, push those threshold recommendations back up into Mainview. So with this solution, you can automate the process of keeping your thresholds from becoming obsolete. So in this example, we're coming into Mainview for CICS, and we're going to select a particular CICS region, and then we're going to determine what metrics that we want to analyze and what data we're going to pull down and do to analyze that data to determine what the threshold should be. So in this case, we're going to pick a couple metrics. And then the next step would be to come in and have Threshold Advisor capture this data and then do an analysis on it. So then once it's done analyzing, it will actually have threshold recommendations. And then you have the ability to automatically push these recommended thresholds back up into Mainview. So again, another example of a closed-loop process that integrates analytics with proactive automation. Because obviously the thought is not only to have a solution that will automatically create these dynamic thresholds, but then you have alarms built on top of these dynamic thresholds that are more accurate. And then when they trip, they're not false alerts, and they can also alert you when something's wrong during your non-peak workloads. Or these days, people aren't really aware of their business cycles. What what CPU should be at 2 in the morning versus, 1 o'clock in the afternoon. We've seen cases where customer systems all of a sudden started using more resources than expected, and they're trying to figure out why. It turns out that maybe there was some type of Facebook marketing campaign that the marketing department put out there without notifying the mainframe IT department that, that 2 o'clock in the morning they were going to go out on Facebook and say that if you log on to your system and do this, you may win a prize or something. All of a sudden, their workload goes through the roof. So these are some of the challenges that we see mainframe IT departments are facing based on, the digital world, the mobile transactions and workloads. So at this point, I'm going to turn it over to my colleague, Ross Cochran, who's going to talk about intelligent capping and modeling.
Thank you, Barry. This is Ross Cochran, BMC Software. So Barry helped us cover how to use MainView to cover analytics, dynamic thresholds, smart alarms. So now that you've got the operating system, CICS, DB2, and IMS, everything on a nice level flight, you're meeting your SLAs, the next thing that will happen is someone will come along and say, hey, let's save some money on a rolling 4-hour average. What's the best way to do that? Well, one of the best ways is to use capping. A lot of customers, maybe even yourself, you've tried defined capacity, you've tried group capping. Well, we at BMC Software, what we came up with is what we call intelligent capping. The vernacular, we call it ICAP. And ICAP is built upon MainView's infrastructure that you just saw from Barry. So all the look and feel, 3270, or the browser-based interface, it's all there, something you know and love. And so if you have MainView, it's a natural add-on. Just think it's a snap-in to help you manage capping with intelligent capping. However, if you're kind of more of a roll-your-own kind of person, we show a lot of the ICAP statistics inside MainView, so you can see what ICAP is doing. So if you want to go in and perhaps use an intelligent dynamic threshold or smart alarm to alarm on something that ICAP's doing, you could also do that. So as Barry mentioned, all the out-of-the-box alarms are available when it comes to ICAP, and all your automation that you have built also blends nicely in with intelligent capping. Here I have a screen capture from ICAP, and what this is, you see the MSUs on the left-hand side, and the importance level are the different levels in the middle. And you can see I have a little bit of importance 5 workload at the top, no discretionary. So kind of a bird's eye view of if I was capping at this moment and using something that we call inside intelligent capping, something called a policy. This is what the policy is seeing at that moment. So if you kind of want to know what traffic is susceptible to an intelligent cap at this very moment, you can see it graphically. On top of the graphics, I have lots of statistics. I have both the 3270 and the browser flavor of both of these. Things such as the rolling 4-hour average at that moment, whether I'm looking at it every 5 minutes, every 1 minute, whatever interval I care to look at it, I can see it. If on a given LPAR I have a defined capacity, and then I have my weight that I've given it, very similar to the Prism weight, ICAP can also use a very similar weight and adjusting or determining the priority for capping for a given LPAR. So yes, there's a lot of intelligence behind the scenes going on, but if you want to peek into what's going on, these are those screens. I mentioned the policy before. Here you see a lot of the policies that we have on our systems here at BMC. Some of them say, have they been validated? Toward the middle there it says validated, yes, or warning, which means if it has been validated, it's a good policy. Everything seems to check out in terms of the priority for the LPARs, the amount of low discretionary or importance 5 workload. ICAP also has the ability in the very middle column called WLM tuning. If your WLM settings were set up 3, 4, 5 decades ago, they may be a little antiquated, in need of a dusting off. If you don't want to go with WLM, You can let ICAP ignore WLM if you wish, or if you want intelligent capping to coexist with WLM, it can do it that way also. So it's up to you. If you have faith in your WLM settings, go with it. If not, let ICAP do it. As you would imagine, ICAP does a lot of work because it's looking at all your LPARs, all the defined capacities, adjusting those as needed based upon the policy that you specify. So there's going to be a lot of information inside our logs, and here's just a snippet of those logs that will show you, hey, here's an LPAR, here's his current entitlement toward his defined capacity. So you've got a really good view into what ICAP's doing. I even had some customers take this data, offload it to an Excel spreadsheet. We all know what that means. Once it's inside Excel, sky's the limit. So not that I advocate that you do that, but all the data is here. Find out what ICAP is doing on a minute-by-minute basis. So what happens if you're not a big person into capping at all? Well, maybe you can help you there. I have an example here on a small LPAR. It's got an MSU limit of 20, and this particular LPAR, the MSU limit has been reached. There's nothing else that can be capped. What happens? Barry mentioned the smart alarms. Well, here you go. I've got one of the out-of-the-box alarms being raised, saying the MSU limit is above 55%, and then I have automation kicking in. So I've got an NVS modifier there to BMC ICAP to go in and set the MSU limit to a particular variable, and now you see the results. That automation in particular was increasing the MSU limit till it caught up to the rolling 4-hour average. You can see right there in the middle where the MSU limit and the rolling 4-hour average met. So kind of a not necessarily intelligent, but what I just showed you, if you're a little bit afraid and you want to just dip your toe into capping, you can with MainView, and have MainView alarm and alert when something's going wrong and put in automation to raise things up. Now, I would recommend, in hindsight, probably just let BMC do it. Let us do it intelligently with BMC's ICAP. ICAP's got 3 modes. As I mentioned before, people have been burned with defined capacity and group capping. So they say, well, Ross, I'm a little afraid of this. Can ICAP ease me into it? Yes, we can. The observe mode is I just sit there and ICAP will look what's going on. Won't change a thing. Won't make any recommendations at all. Message mode, a little more aggressive. I need a policy, so you need to tell me what to do. So once I see something happening, I don't do anything. I just say, hey, I saw this, and I would have done this. Would have saw this, and I would have done this. So kind of a cause and effect relationship. And then the manage mode is where I actually start doing something. I see a value that needs to be incremented, maybe a defined capacity, and I will actually make that change. And then secondly, if I see something else that needs to be changed, I will make that change. As the note says there, it makes the calls to the BCPII, which is the IBM Hardware Management Console. That's how we make the changes to the DCs. Here's an example of some workloads by importance, and at the top I have the lower importance workload, and I have this concept called an MSU green space, meaning there's probably some room here that I could probably go in and cap this particular LPAR. Now, the reason I have done this, I have gone inside the BMC Cost Analyzer for Z Enterprise, which is another solution set from BMC, and I've said I've got X amount of green space. How much money, because that's why you cap, is to save money, how much money would I save if I were to cap that given LPAR at that given rate? And you can see here down at the bottom, around $4,000 a month. So times 12, how much per year, you can see that it starts adding up. And then you can see that $4,000, how it was derived. I have savings all the way from ZOS, MQ, Cobalt, DB2, and CICS. So savings across the board when I start implementing intelligent capping. Here's some examples of some companies. A bank, transportation company, a large insurance company, all had varying degrees of success by using BMC's rolling 4-hour average optimization solution set. You can see the numbers over there on the right-hand side. Quite impressive, so it does make sense to look to someone like BMC to help you manage your rolling 4-hour average. So to kind of wrap it up, here's the closed loop that Barry started out with, and I'm on the far left-hand side. So you're going to make the changes to capping to start saving money, model the change before you put it in, start saving the big bucks, and then analytics is going to kick in again to look at your new numbers because you're going to have a different MSU limit. You're going to have some different defined capacities. Things are going to behave a little bit differently. Analytics, make it run better, put in some automated operations, and here you come again. Start capping again. So it's a continuous improvement closed loop process. And that is all that I have. Jasmine, do we have any questions from the audience?
Yeah, we had a few questions come in that I'll read off. Just a reminder to all attendees, you can submit your questions through the QA box on your toolbar. The first question we have is, my company wants to lower our MCL bill. We have used the competitive solutions and we weren't successful. Why would your tool be any different?
I'll take that one since I was talking about capping. Why we tend to be a little bit different is that we looked at what is in the marketplace, in other words, defined capacity, group capping. We found, like in a lot of BMC solution sets, we have found kind of the weak spots in the current existing technology, and that's the value add that we bring, is that we know the weak spots. In other words, when Prism locks up all of its WLM tuning, when a capacity is hit, we overcome the known limitations in group capping and defined capacities. So we understand the limitations of the native offerings, and that's our value add, to plug those holes and to have seamless, worry-free capping.
All right. So our next question is come in, and it says, modeling sounds good, but I need more details. What kind of data would I have to provide? How long would it take, and how accurate is it?
All right, I'm going to jump in again. Sorry, Barry. Yeah, modeling does sound good. You need, as in any kind of modeling, the more data points, the better. I recommend probably a month's worth of data. Now, why I say that is in a month, you're going to hit your rolling 4-hour average. So knowing where that is, and that is your bogey, that is the data point you're going after to start saving money. You'll lower the R4, you start saving money. So run at least a month's worth, and it does come from SMF data, your typical SMF type 89, 1s and 2s, and your 70s type 1s, standard SCRT type numbers. That's what it takes.
All right. And we have another question. Managing our 4-hour rolling average is a good thing, but I have nightly critical batch work and a shrinking window. How can I get my batch work done and avoid getting a bill?
Okay, Barry, I promise this will be my last one. There's a solution set around Mainview Batch Optimizer, and it is called, around Mainview, I'm sorry, it's called Mainview Batch Optimizer. And what Mainview Batch Optimizer does is if you have a finite window to get batch done, and I know we got to have the all lines up by whatever, 4 a.m., 5 a.m., 6 a.m., finite window. Mainview Batch Optimizer will go out and take the job, break it apart between its separate steps, and then if step 2 doesn't have to wait for step 1 to complete, it'll go ahead and run step 2 at the same time step 1 is running. So as long as there's not a prereq, correct built into the job, and I know there's a lot of that, sometimes there's not. So other jobs can be go ahead and run it ahead of schedule. That way, a given job, instead of having to wait for step 1, 2, 3 through 10 to complete, it may only have to wait for 7 because the other 3 ran already. So that's how we can condense the time that a given batch job can run. And Barry, I promise that's all. Go ahead,
and we have a few more questions. I can see how automation would be helpful if it solves a problem without causing another one. What are some best practices I can use to be sure I do no harm and really solve the problem?
I was going to let Ross answer that one, but it sounds like it's more appropriate for me. Yeah, so we talked about automating problem resolution. I think I gave a kind of a simplistic example, but really, what you really want to do is to use our automation that has a more sophisticated algorithm that determines what action you should take and if you should take an action. I have one large customer that that runs MainView Alarm Manager, and they actually they run it in warning mode. So instead of MainView going out and actually taking direct action, they have the automation pick up the warning when an alarm trips. And then they have a sophisticated algorithm that says based on the transaction or the time of day or the workload, what action should be taken. Maybe they should cancel something. Maybe they should just notify something. Maybe they go out and check other metrics at the same time and make sure that the problem is being profiled correctly. And maybe it's just not CPU, but they go out and check 4 or 5 metrics in order to determine the nature of the problem before they take some automated action. I notice one customer, every time they get a new application, they notify the automation team, and they have to put these application rules in place. So, this is kind of another example of intelligent automation where it's just not simply, detect a threshold and then blow something away. Really, this is why you want to use some type of integrated automation solution, is where you can be more intelligent and really understand that it is the problem you think it is, and then automate the resolution to it.
Okay. And next question, we use Rex for our automation. How much can you really automate with rules-based automation?
I think that's for me, Ross. Yeah, so I think, I think we had a slide that said there was the 80-20 rule. And we actually find that that's valid. We have a lot of customers that use our automation, and not only are they using our automation, but in many cases we convert it from another automation solution into ours. So you take an example of like maybe they were using a competitive automation solution and it was all done in Rex. And then we come in and we assist that customer with the conversion into the BMC automation solution. And what we found is that generally we can do 80% of that automation using our rules engine, and then the remaining 20%, has to be done with their existing Rex code. So, again, I would say that the rule is about 80% of your automation can be done with rules, and then the rest would be with Rex routines. And this would, even customers who are just starting out with automation, or customers that are converting, and maybe currently 100% of the automation is in Rex. And if you would convert to BMC, you'll find that you could do 80% of that with rules. And, we talked about the 4 components, the system startup and shutdown. So typically, we can handle the system startup and shutdown with no Rex code at all. Whether you're using Total Object Manager and doing it with objects, or you're doing it with rules. When it comes to event management component, where you're taking action on alarms or other events, that can be done almost strictly with all rules and no Rex code. Same thing with the console message management. So our rules engines allows you to create rules that will trap a console message and then take some type of action. And then in some cases you'll find that you can't do it with a rule, so in maybe 20% of the time you'll have to use Rex code.
Okay. Next question. The smart alarms you talked about sound useful, but we have a lot of systems and LPARs. I don't have the time to manually manage that. Is there a way around that?
I think that kind of centers around the one way would be the threshold advisor that we talked about. So that was kind of the whole point of that solution, is to alleviate the burden of trying to define the thresholds that the alarms are defined on top of, particularly in large environments where you have lots of LPARs, you have lots of subsystems like CICS and DB2, and so we found that, and we didn't just dream this thing up on our own. Threshold Advisor was really a end user enhancement requests. So some of our larger customers have found that it was difficult to go out and define alarms and to create the thresholds manually. And they asked us if there's something that we could, help them out with that. So we developed Threshold Advisor, working with the end users who asked for that solution. So besides just defining the thresholds, we do have out-of-the-box alarms. So, obviously you can define your own alarms, but we do provide out-of-the-box alarms for all the different Mainview solutions, whether they're CICS, DB2, or ZOS IMS. We also have an inventory of best practices. So obviously we work with a lot of our customers implementing Alarm Manager and defining alarms, and so our software consultants actually have an inventory of best practice alarms. I find that in most customers, they take one of two approaches. So the first approach is to kind of define every alarm for any type of thing that could ever go wrong. It's what I call like the fishing net approach, where you may define hundreds of alarms that would trap almost anything that could go wrong. Then I have other customers who they take the opposite approach, where so every time they've had a problem that caused some type of downtime or outage, then they would have like a post-mortem, and they would determine, is this something that we could define an alarm for and get some type of proactive notification and avoid the outage the next time it may happen. And so over the years, they've ended up with about 100 to 200 alarms, and each one of those alarms actually represents a real problem that they've experienced in the past that actually caused an outage or some type of issue. And so again, two different approaches, but we do have these alarms in an inventory that when we go to new customers, we can recommend some best practices.
Okay, so those are all the questions we have. So if we don't have any last-minute questions coming in, that will conclude today's webcast. We'd like to thank everyone, especially Ross Berry and the BMC team, for attending the event today. This feature will soon be available on SHARE website at www.share.org. There's a survey after this webinar for you to complete. We thank you in advance for your feedback, and thank you again for attending today's webinar. And everyone have a great day.